Hey guys, welcome back to another video. So today we will be solving 1DDP problems. The problem is house robber problem. It's a very nice and important. So we are going to solve this type of problem. Let's see how it is. Back to another. So we'll try to solve this type of problems. Let's first. You are a professional robber planning to rob houses along the street. Each house has a certain amount of money stashed. The only constant stopping you from robbing each of them is that the adjacent houses have security systems connected to it, and it will automatically contact the police if two adjacent houses were broken into on the same night. Okay, got it. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, got you. So here the problem says is that you have some houses and it has some like things to take out. Like you rob here, you get one some price thing, let's say. You rob here, you get two price. You get rob here, you get three price. You get rob here, you get one price. And get the maximum profit or maximum, like after robbing, you get the maximum things. And there is a constant return in this problem is that you can't, like in one night, you can't rob adjacent houses. Otherwise, police will come and arrest you. So you have to take like non-adjacent. Let's say 1 and 3. You get 4. So money is 4. You have to take, if I take 1, 1, it is not. It is not worth. Got it. So, uh, okay. And here if you see, you take 9, 2 is 11. 7, 3 is 10. This house you rob. Okay. Okay. Okay, I got it. You take this and this and this. Non-adjacent. Yeah. So you have different options. So this problem is a recursion type. Why? Maybe asking why. Why it is a you only think of recursion? Because you have choices. If you add this, like let's say all I do from 10 to the start. So if you are here, you can't move here. You can move here. You can't take, you not take, you take it. Take not take things. Okay. You take not take, take. Let's say take it. Okay. Then we get like in here it's also not take take. There is a different choices we can have and we want the maximum. So get the maximum. That's why we are going to solve it by recursion. any problem you do, at first you should write things in a notebook. First, you should solve it in your notebook. Then try to code it. Like pseudocode, you can write the pseudocode. It is helpful, obviously. So what we are doing, let's say, take an example. Let's take this example. 7931. Okay. And we are, this is starting from n minus 1. Okay, we are at this stage. There is a choice of, let's say I'm not taking, obviously we are not taking it. If we take this, there is also choices whether to take it, whether to take this, not take, not take. So there is two choices. Okay, take, not take. Okay, so function will have, let's say n minus 1, that is the index. Okay, that's last index. So we'll take, if we take, okay, if we take it, so the array of n minus 1, that is index, array of index plus that index, we take it. If we take it, then we can't take the n minus 1. So we have to solve for I minus 2. Okay, if you have to solve for I minus 2. And if you not take it, let's say we do not have taken it. So obviously 0. And you can solve for I minus 1. What does f of n minus 1 signifies? It signifies the maximum, this maximum amount of money you can rob. Maximum amount of money, non-adjacent maximum you can rob. Okay, so that this if function uh, says, and at last you have to return something, obviously maximum of take and not take. Got it? Then you have something called base case. So what is the base case if you want me to ask? Then the base case would be pretty simple. Why? Maybe asking. The base case is the base case would be index is 0. Okay, so the index is 0. If it is become 0, it has become 0. What does it mean? We have reached here and we haven't take the one index. So we want to maximize the profit, obviously. So I have to add the, okay, return array of that index. Maximize the profit, obviously we have to add it. Okay, so if I is less than 1, 0, that means return 0. This is the recursion, and you want to memorize it. Pretty simple, doesn't require that much of time. And so what we are doing, we are just, let's say first of all make us n nums dot size, and then we are returning, oh, return solve. Obviously we need nums and n. Okay, so now in solve we need nums and we need, let's say index would be n minus 1 because we are doing it arrays 0 with 0 based indexing. So here is a take, not take, so 2 to the power n is the thing. So it should be like 20 or something, but it is 100 length is given, so it is obviously it should be a DP solution. But in DP solution you should know how to write the recursive code. then only you can go to memorization, then only you can go to the tabulation, then only you can do the space optimized solution also you can write. Okay, so the best case would be if index is 0, let's say. Okay, return nums of I, and if I is less than 0, that means okay, 0. Then we have two choices. Int, let's say we are taking take. So if we take it, so nums of that current index you are taking, so you just add it and solve for nums I minus 1. Sorry, I minus 2, because you have to solve for I minus 2, not for I minus 1. I minus 1 will not give us the not take. So I minus 1 will be in the case of not take. Let's say 0, obviously, because you are not taking it. You are not taking it. So what will be the uh, don't write it. Doesn't mean anything. So uh, solve norms I minus 1. Solve for I minus 1 because you have processed it. Should not need to process it again. So maximum of hopefully it will work. Okay, it will work as a recursive solution, but TLE will show up because yeah. But if you submit it, it will show TLE, which I don't want. So uh how to get out of it? So we can make a vector int vector dp, let's say dp, which will have size n plus 1 and uh uh minus 1. Okay. Now before doing this, dp of, let's say I or something. Yeah, I save it, and if dp of I or not equals to minus 1, return dp of I. Okay, so here you have to something which is like, wait. Um, yeah, yeah. So pass it by reference, and you have to do this here also. Now hopefully it will now work. Let's see. Okay. Where? Okay. Deep. Yeah. Now let's see. Pretty nice. Yeah. So see, 100% solved. Now you can do something else, that is tabulate it. You can tabulate it. How you are going to tabulate it? This is also pretty simple. You can say pretty simple. How you want to tabulate it? See, let's take one thing and just I'll change here like dp of 0. Yeah, I less than 0 though doesn't require. If it is less than 0, okay. Okay, it is 0. Okay, or a minus 1. Okay, so you remember this. You just have to memorize it, and okay, now it doesn't require. So for int I from 1 to n plus plus obviously equal to n, and what we're doing, we are um okay, we have already used I, so we can't use I. Yeah, I just don't record this thing. Just dp of 0 plus this equal to add so that we get the maximum. Got it. Get the maximum. So for int 1 to n, I think, because n up to 1, n minus 1 we have to go now. I think so. We'll see if it is, if it will show error. I'll change it. No matter. It's not a very big deal. Now, what are we doing? We just if uh if I want to tabulate it, so of to like take not take now. So when we're taking like dp of okay, okay, yeah, yeah, nums of I and dp of I minus 2. If you are at index, let's say 1, then we have I minus 2, it will be minus 1, which is not a valid thing, which will return 0. So what you should do, you should do like yeah, yeah, so what we're doing is that we are dp of I is equals to is the initialization and then the base case thing, and then if it nums of I. So you are taking now, so you are taking, so y is 2 nums of I. Yeah, if I greater than 1, is a where is less than 1, if it is equal to 1, so it will be a 0. So this one, we don't need to add anything. So if it is this thing, so we can just dp of I plus minus, oh, we can add something called dp of I minus 1, and you can do like dp of I is equals to dp of I minus 1. You don't take it now, don't take it, and get the maximum out of this too. Wait, let me just think, because I think there is some error that I can feel. Okay, if I understood. I think it will be take and not take only. Int of not take, not take. Yeah, yeah, I think so. Take, not take, and we are just adding it to the take. Okay, and get the maximum. The maximum of taken, non take, and at last have to return something. So dp of n. So, but in minus 1, in minus 1, because we're doing like 0 and 0 based index. So obviously in minus 1, I think so. Oh sheesh. Oh my god, bruh. S- mm. Okay. Ah, got it, got it, got it. Yeah. So, um, mm, yeah. So can store it to GPFI. Now let's see. Oh, it worked. It worked. See. So here you're having big of n and big of n for recursion and all. Here you are not having that thing. So here will be big of n. Now you can more. You can do more stuffs on this. That is space optimized solution. You can write a space optimized solution here also. So what we are doing is that we can just have a previous one and a previous two. Oh yeah, previous and previous two. So if you have a previous, that will be like it will be like the previous. Okay, it will be previous. So previous two would be one. Would be, let's say, zero. Negative. Let's think of that. Okay, negative. Okay. So first case only one thing is equal to remember. So I'm minus two will be previous two, and M minus one would be before element. I think. Oh shit. I think so. Previous. Okay, and I have to change also. So current and previous. So we and yeah. So I think here will be equal to sign because like current will be like somewhere out and okay. I think let's see if it doesn't work. That means it will be equal sign. Okay. Okay, I got it. It would be like int. It would be like int. Uh, okay. Be like int. Okay. And I am pretty much happy with my solution. Hopefully you have understood second problem. Uh, and my internet is good or not? I don't know about that, but hopefully it is a good internet because it is working on my mobile now. So you'd never know how it is going on. Pretty much happy with my solution. Hopefully you have understood. So let's houses that we at this place arranged in a circle. That means the first house is the neighbor to the last house. Okay, these and this are the neighbors. These and this are the neighbors. Okay, maximum pretty simple. I can solve it pretty simply. First of all, you think how you gonna solve it. How? I'm giving a hint to you that it is solvable by previous logic only. And there is slight difference, very slight difference. Just a simple slight difference you can get in this solution. If you can get it, it would be very nice. It's a pretty straightforward problem. And if you have already understood the previous problem, nicely, then it would be a cakewalk for you. It would be a very easy solution for you. So first of all, think how we're gonna solve it. So there is a problem says that you have like some stashed money in some in, in the houses. Let's say 0, 1, 2 houses in the array. So you have something, and the first and the last are the neighbors. There is a circular, some you can think of a circular type of like arranged in a houses, like circular type. And you are going to just rob house. Okay, so I think you have understood the problem. Now let us solve this problem. What we are going to do? We are going to pass the substring from start to the end minus 1. That means n minus 2, let's say. So that means we are passing these two at first, then these two at first, and get the maximum. And get the maximum of the profit because they are the neighbors. We can't put this and this, drop this and this whole together, and give this and get the maximum. Hopefully you have understood. Hopefully, because it is a pretty simple solution. It is a very pretty simple. Get the nums. I'm just copying and pasting this solution because it will be similar. What if this would be not the thing now? I would be like, bro, what? So what we're doing is that we just have to pass. Okay, wait. If we're solving with this solution, what do we want to do? Okay, yeah, so what we will do is that we are going to is the space optimized solution now. So mm, okay, so um okay, so I think so. So I was thinking pretty nicely. So see, I'll just write as something like called as some we'll get a substring from, let's say, okay, for int I equals 0 I less than nums dot size plus plus. Okay, if I not equals to 0, we call it temp1. So temp1 would be if I is not equals to 0 now. Oh, okay, you have to make it. Oh shit. Temp1 and let's say temp2. Can make this. I so temp1 and temp2 we have made. So temp1 push back. Temp1 dot push back. Nums of I. If I not equals -1, temp2 dot push back nums of I. So now uh, max of return, obviously return max of solve for temp1 and solve temp2. Become optimistic, bro. Int solve, obviously what a vector we have is a sub vector. Just copy and paste it. Just change the name. Solve. Oh, let's a vector or something. The V. Yeah. V. V. Yeah, yeah. Call it V. I can just do something like that, but hopefully, it will not work. Um, ha. Undeclared identifier nouns. Um, ha. Runtime error reference boolean null pointer type int. Oh, what? Why is showing? Why it is showing error? Should not provide. It is very. Oh my god. Oh. Hmm. Okay. Yeah. Why undefined side is something, some, some. Oh, got it, got it, got it, got it, got it. You can see that. Yeah, you have to think now why this is showing. Something is wrong or something is you are missing. You have to understand that. You have written for like 0 to n and all these things, but you haven't written for if it has only, let's say, one thing, like one index, then we have to return that thing only. If let's if nums dot size is equal to 1, that means one index, so return of 0, that means get the thing base case and all these things you have to think. Otherwise, it's very help, like it is not good for you to solve this type of problems. You can't solve it. Can't solve it. You don't know how to solve. In this case, you have to think. This is the simple but complex stuffs you have to remember stuffs. And this is for today. Hopefully you like this video. Like, share, and subscribe to my channel to get more this type of videos in the ongoing, let's say. I'm gonna post regularly. I will try to post more regularly, and hopefully I will get some internship or something in some company or some. My dream is to get into like Google or something, but this is very hard nowadays. But I will try. I will try. I'll grind. I will grind. No matter what, I will grind, and it would take some time. I know. Might be this is not the right time to get that thing, but it will come if I like go on, and if I like this, and I know that it is very interesting. It is very interesting to study like DSA and all these things. It is very nice and very informative, and it is very like we can say interesting. Though it makes me complexify my brain, it is very complex. Sometimes it becomes some complex. But because why it is being complex? Because you don't know the concept. You don't know how to solve that problem. And if you have already solved that problem, you should remember that problem, how you have solved it. However, because you solve it doesn't make you a good code or something. You have to remember the pattern. You have to recognize the pattern also. You have to understand the pattern. And thanks. You have understood my